Hello, and welcome to the very first Beneq special product event. Often known as the home of ALD, today Beneq is known as one of the leading providers of atomic layer deposition equipment and services. We believe ALD could become an enabling technology for many more industries and applications than currently in production. In 2021, we're seeing greater demand than ever for our products. So we're glad that you could join us today for some exciting updates and announcements. We will share the latest developments on our products, including research and development, semiconductor wafer manufacturing, batch production, and spatial ALD. There will be a 10-minute questions and answer segment at the end of this event. First, let's start with the Beneq TFS 200. It is one of the most installed and flexible ALD research tools in the world. Here's Tommi to tell you more about it.
Hello, everyone. My name is Tommi Kääriäinen from Beneq, and I'll give you a short introduction to Beneq TFS 200 ALD system. So the Beneq TFS 200 is basically a research equipment platform that grows with you. It's been especially designed for a multi-user research environment with variable needs. The large number of product options and upgrades means that TFS 200 really will grow with you to meet the most demanding research requirements. The TFS 200, basically it's a compact in size, has wide temperature range from room temperature to 500 centigrade. It allows deposition of variable shape and size of substrates from single wafer to wafer batch and to 3D objects. The system is available with large number of precursor sources and has thermal and plasma ALD capability. And it also comes with easy to use user interface. The Beneq's design or chamber design principle that follows the other tools as well is basically provides extremely high temperature uniformity, meaning that you don't really have to worry about the so-called cold spots in the reaction zone. Reaction chamber has only metal sealing surfaces and there is no deposition on vacuum parts such as on O-rings. This basically makes the maintenance like cleaning procedure extremely easy and tool safe to use. The TFS 200 users can choose from large number of options to have the most favorable system configuration. So options include large number of precursor sources, load locks, plasma ALD, high aspect ratio option with either with the reduced or stop flow modes, several different types of in situ analysis options, and also the particle ALD with the fluidized bed reactor. The system is very easy to switch between the reaction chamber modes, for example, from thermal to plasma, from single wafer to batch, and from wafer to particle ALD. And if you have any specific needs, we are happy to discuss the customization for the TFS 200. And maybe an example for this, I can give you the most recent developments. So as a new product option, we can now offer the transfer module with automatic cassette loader. The integration to the transfer module can be two independently configured TFS 200 ALD reactors, where one, for example, can be thermal ALD and another one plasma processing chamber. Or the reactors, these two different reactors can run two different ALD chemistries. Obviously, these type of integrated systems can provide higher throughput and also allows, for example, multi-layer coatings without breaking the vacuum, which is beneficial if the ALD film material is air sensitive. Alternatively to automated cassette loader, the load lock can be a lower cost, simple manual version, where again the integration is also two independently configured TFS 200 ALD reactors. So this with this new product option, I would like to welcome Dr. Stephen Christensen from National Renewable Energy Laboratory to tell about his studies and user experience on TFS 200. So Stephen is one of the TFS 200 users, and we're happy to hear his view on using this system. Welcome, Stephen.
Thank you. Glad to be joining you guys. Let me share my slides and screen. Can you see it?
Yes.
Okay.
Go ahead,
Great.
Steve.
All right, so I'll be talking about our work with the Beneq TFS 200. To go into more detail, I'll be talking to you today about project progress in hydrogen storage materials and applications. So our Beneq ALD family consists of an 2011 TFS 200, and then we recently, this is actually model year 2020, but we are still installing it, so it's getting put into place, and I'm actually not the person doing that, so I'm happy about that, but we're making progress. And in 2019, we also went with the fluidized bed reactor, and as we get the second tool installed, I think we can start using that more frequently. That's kind of the goal. And we might be in the market, just kind of hinting at Beneq that 2024, my management claims that we'll have budget for it then, so we'll see. But to give you an idea, we are at Golden, Colorado, and we're basically a Department of Energy funded lab. Our name says renewable energy, so that kind of makes sense. A lot of the work that we've been doing over the years has been in solar cells, catalysts for biomass and fuel cells, a little bit of work in battery, and then recently I've had a project in hydrogen storage where we're starting to get some interesting results. And we'll be talking more about that, but we recently had our first paper on this project by Noemi Lake. And so, yeah, let's talk about metal hydrides. So as I said, we're funded by the DOE to do work on metal hydrides or hydrogen storage applications for currently light duty vehicles. DOE has set targets for those at the weight percent, performance, and some of the ones that are most relevant are the system hydrogen capacity, and their goal is currently 5.5 weight percent for the system. And we also want to fill the hydrogen in 5 minutes. These are actually very, very difficult goals to meet. You can see this chart down at the bottom where metal hydrides as materials have a ton of hydrogen. They can have as much as 18 weight percent of hydrogen, but the operating temperatures of those means that when you engineer them into a system, you lose a lot of system capacity because you're adding in weight for balance of plant and thermal management and other aspects of the tank. And so we are trying to get those numbers down, improve that kind of performance. And one of the things that has been touted over the years is confining metal hydrides in nanostructured materials, and also adding chemical additives, which are basically the hydrides world for catalysts.
Hi. Calling to let you know the link is incorrect for Beneq. Okay.
Okay.
All right.
So anyway.
Yeah, but it's not where it says to join via Microsoft Teams. Click here. It's not there, but it's down in the little logo.
Can everybody hear me? There
below.
might be somebody else on the line, and if they could mute, that'd be ideal. Thanks. All right, so so back where I was at. So nano confinement has people have looked at porous materials like carbons and other things to infiltrate the metal hydride into, but we wanted to try the reverse of that, where we coat a metal hydride with ALD coatings and add in additives and hopefully be able to pull off some of the same kind of results and actually do better than a nano confinement strategy. So a lot of our work initially started with magnesium boron hydride. We put aluminum oxide, some metals, cerium oxide, and titanium oxide. And basically we had some interesting results. There's more work evolving from that. But what we did get from that was the use of nitrides, or what I call nitrides. And titanium nitride is what we'll be talking about a little bit more. But basically that evolved from a need to get away from things that have oxygen that might actually kind of kill the metal hydrides, produce unwanted phases that don't cycle with hydrogen. And so let's talk more about where we're going with nitrides. So the material that we chose to kind of evaluate is sodium aluminum hydride, or sodium alanate. This is an interesting material. It has not a ton of hydrogen, but it has a reasonable amount. And in the 90s, late 90s, there was a really cool result where the adding of titanium via titanium 3 chloride, which is a solid, by ball milling it in, they saw rapid hydrogen rates change in both the charging and discharging of the metal hydride. And what I've got on the right here is kind of a desorption graph. The bottom is our temperature profile. And so the blue curves, and we have one other data, so just kind of keep in mind. But the blue is when hydrogen is being discharged from this material, desorbed, and we just measure that as a negative amount. And then absorption is positive, so pink, and so that should show a gain. And so when neat or unmodified sodium alanate is heated, you need to get it to pretty high temperatures to actually get most or all the hydrogen off at 380 C. It actually melts at 180. So you go through that melting transition and still going up. So titanium chloride changed all of this. But there was some trade-offs that happened, and basically they ball milled this in kind of clumsily, if you ask me. And ultimately what happens is a product, this isn't balanced, but a product is sodium chloride that's not going to absorb hydrogen easily in any reasonable conditions. And so there is a rate increase, lowered temperatures, faster hydrogen on and off, but you lose capacity, and this is kind of just not really possible for this technology if you do that. So we wanted to say, well, okay, let's take a look at ALD and the titanium.
Steve, looks like you are muted.
Sorry about that. Okay, so sodium alanate. So we coated this with a structure, the particles we just got from Aldrich, coated with this titanium nitride layer we have, which is basically titanium chloride plus hydrazine. We're working on kind of characterizing that further. And then I added in aluminum oxide to hopefully give it a nano encapsulation effect, and so to improve the cycling as we move through hydrogen on and off. So initially, right off the bat, this material performed very well. So we were able to get the full capacity off at the first cycle. I hope you can see this first cycle over here. And then hydrogen absorbs pretty well, and we cycle back and forth. There's a little bit of temperature up and down as we're mapping out these conditions, but ultimately, let me back that up. Ultimately, this desorption and absorption behavior became very fast, where you see very steep on and off curves, and this is kind of ideally of like what we had hoped for. Our average is getting up to almost 5 or 8%, and the kind of the most important thing here is that the titanium nitride that we put on here, if we grew a standard film, I would expect about a 1 nanometer about a 1 nanometer thickness. So this is a very low coating for this material to start to perform this well. We've characterized this. I'm going to go fast here, but basically we see no formation of chlorine products. We do see titanium. The materials kind of cycle as we go through at different pieces. We've used XRD to confirm that we're cycling between the two reactions we hope to, which is sodium hydride going down to the two different things, and we kind of stop at this reaction 3. So that's all good. And again, no XRD shows sodium chloride. And so if we kind of circle back to this, then we can start to put these ALD numbers on the map. And I don't have my mole percent titanium yet. We're working on getting that, but basically it looks like extremely low loading is giving the results that we want. So we're pretty excited about where this ALD technology can take us. And basically, I'm out of time. Thanks for your attention, and we'll be answering questions at the end of the session.
Thank you very much, Steve. That was a very informative presentation, and we like to definitely hear more. And please stick around to the end of the session. During the Q&A, there will be an opportunity to ask Steve or Dommi any questions you have on their presentations. Now, as introduced earlier, we have a very exciting lineup of additional speakers from our headquarters in Finland, in Helsinki. Unfortunately, due to the time difference, they are not able to join us live. Here's what they have to say about some of our exciting new products.
Welcome to the Beneq R2 product update. We launched the Beneq R2 2 years ago at ALD 2019. The R2 is meant to be an affordable entry-level ALD tool. It's based on a flexible configuration that you can easily add options to. This ensures fast delivery times and user satisfaction. The tool is designed to be used so that everything works in a straightforward manner and it's ergonomic to use. The R2 still comes with, as a standard, a set of 4 liquid sources, a single wafer thermal chamber, a spare part kit, commissioning, and of course, training. What we've been really working hard on for the past 2 years are the options that are addable on the R2 and the processes relating to these options. There are multiple options you can add to the R2. All of these options are intended to increase the capabilities of the tool. There are chambers and there are sources. For example, you could add a 3D chamber and then a set of heated sources. The standard wafer chamber for thermal processing is for up to 200 millimeter substrates. The uniformity levels are high, typically for standard oxides at a level of 1%. The profile of the film is characteristic of cross-flow ALD. For plasma processing, we offer a plasma chamber that relies on our 300-watt capacitively coupled plasma source. It is usable in both remote plasma mode and direct plasma mode, and it's easy to exchange between the two. For the 3D chamber, this is meant for larger parts or wafer batch. We found that the homogeneity between wafers in the batch mode is really good. For low vapor pressure precursors, we offer a set of 2 heated sources. These are 200 milliliter volume containers that are heatable up to 200 degrees C. They can be utilized in both direct vapor draw and load and release modes. An example process would be hafnium oxide. Then for stronger oxidants, we offer the ozone cabinet option. So this is a safe way to deliver ozone with the tool. It contains a cabinet and then an ozone destroyer for safe disposal of excess ozone. Even at high temperatures, this option provides good uniform films.
Hello, my name is Mikko Saikkonen, Business Development Manager at Beneq, and I'm introducing and presenting Genesis ALD roll-to-roll system. The motivation for the roll-to-roll ALD is the main three market sectors: next generation batteries, passivation and for cathodes and anodes, and thin film coatings for solid state batteries, conductive layers and encapsulation for the flexible solar cells, and moisture barrier for flexible electronics. Beneq started to develop roll-to-roll ALD already in more than 10 years ago when we developed TFS 200R for R&D for continuous ALD. Following years, we developed real roll-to-roll systems, and just recently, earlier this year, we launched Genesis ALD. Roll-to-roll Genesis ALD is based on the E&R Vacuum's roll-to-roll platform. It's a compact size, as you see the dimensions. The length is about 5 meters and width 2.2 meters. It has all the ALD basic components and functions, including the coating head, precursor cabinet, filter system, vacuum pump, and electrical and control cabinet. Web types can be copper, aluminum, stainless steel, polymer, and basically all the web materials which can be done in the web vacuum coatings. Web thicknesses are from 6 micron to 200 micrometers. And all basic ALD materials are demonstrated with our roll-to-roll process. Process maximum temperature is 250 centigrades, and dynamic deposition rate is 10 nanometer times meter per minute. The ALD coating head is maximum for 420 millimeters, which equals to effective width of 390 millimeter. The drum diameter is 870 millimeter, and maximum temperature is 250 centigrades. Genesis roll-to-roll has two operating modes. Static coating head mode is for thin, like a 1 nanometer film, and then the process speed is up to 30 meters per minute. For the thicker films, coating head can be oscillating, and then the line speed or the process speed is 1 meter per minute for 10 nanometer film. As an example for how the roll-to-roll ALD can fit to the industry needs, here is an example for lithium-ion battery value chain, and ALD can be fit to the cell component manufacturing or cell manufacturing processes. Beneq roll-to-roll ALD gives a direct scale-up to the mass production for protective coatings on anode, cathode, and separators. Coating on particles also in roll-to-roll is possible, and roll-to-roll for suitable 3D structures. And for the reference, 1 nanometer of ALD coating cost of ownership is less than $1 per square meter. Beneq has already R&D, research, and pilot scale equipment available, and larger production systems are available as a custom design. Thank you for your interest, and we are happy to discuss further about your ALD needs.
In this product's special event, I'm excited to share an overview on the Beneq Transform ALD cluster platform, and specifically talk about how that platform can be used for technology development and bridging over to pilot scale manufacturing. Beneq Transform cluster tool is a very versatile platform dedicated and engineered for the more applications. By definition, it means that the platform is able to handle a broad range of wafer sizes and wafer types, as well as able to deposit a broad range of functional films. Versatility emerges from the combination of thermal batch ALD as well as single wafer plasma ALD. The user is essentially able to extract the best of both worlds for the targeted film function. Another benefit in this platform is a preheating module. We're taking wafers individually from the load block, preheating them, preconditioning them, and then loading them onto the thermal batch module, essentially eliminating any waiting time on the module. The tool is fully fab ready. It comes with a very standard single wafer, horizontal wafer automation, and we can cover wafer sizes from 3-inch indium phosphide to 8-inch silicon or GaN silicon, for example. The tool is S2, S8 certified and comes with standard SECSCAM fab communications. The tool is also designed for ease of use and serviceability. The platform comes with a broad range of thin film processes. Each of these process modules houses four heated precursor containers, 2 gas lines like ozone and ammonia, as well as up to 3 plasma gas lines. And you can imagine that the combination of different films and processes is very vast. Just mentioning here some of the common oxides and nitrides we can deposit on the platform. The platform comes with 2 main frames. Beneq Transform is able to house up to 3 process modules in addition to the preheater. Because of the larger transform module, which is the Brooks MX600 Super 6, the mainframe also has additional features like buffering as well as cooling integrated onto the transform module. Beneq Transform Lite is a smaller version which has a MX400 transfer module, which equally well can house the same process modules, be it either thermal or plasma, but this is net limited up to 2 process modules in addition to the preheating module. Both platforms can handle wafer sizes from 3-inch all the way to 8-inch and have the SECSCAM communication capability. As a reference point, we give a figure of merit for 50 nanometer aluminum oxide. So the thermal batch process modules is able to generate 15 wafers per hour throughput from just one process chain. You may be asking, what kind of applications can I address by using this platform? The answer is actually very broad range of applications. We're showing here key market segments addressed by the tool, which are ranging from power devices like silicon carbide and gallium nitride, RF devices, RF filters, MEMS and actuators, image sensors, as well as micro LED or OLED or photonics application. Across these market segments, we are depositing a range of functional films covering applications and requirements for gate dielectric or MIM capacitors, surface passivations for silicon or compound semiconductor, nucleation seed and barrier layers, chemical barriers, thin encapsulation of devices, as well as optical films such as anti-reflecting coatings. Now you may be asking, what can I cover with thermal batch and what can I cover with plasma? Thermal ALD oxide process, also some nitride process, are well capable of addressing broadly these market segments and applications we described. But we've identified specific interest for plasma to enhance the film property and device electrical properties across these 3 categories. Specifically, you look at compound semiconductor power, for example, gallium nitride or silicon carbide, where interface states is an important factor. Plasma clean and plasma deposition combined with oxide deposition is providing additional benefits on the platform. Similarly, if we talk about surface passivations, commonly low temperature nitride processes are used, which are enabled by plasma capability. Further interest is within the nucleation seed and barrier layers, where a plasma-based process can further provide attractive features on low temperature nitride films. Finally, I want to walk you through how the Beneq Transform Lite tool can be used for initial technology development and then be utilized for scaling this into pilot scale or even volume manufacturing. Technology development is about screening materials and looking at integration and resolving integration challenges. And there you may have, again, the need an interest to explore two types of processes, either thermal or plasma. If you go for thermal process, you have a choice of 1, 10, or 25 wafer batch size. Again, something that can scale as your interest and needs scale. A further point I should raise is that with the plasma module, you may combine plasma as well as thermal processes. So those oxide I mentioned are also available on the plasma mode as a thermal operation. So you have a very large range of different chemistries and films you can deposit. And by the automation and sex communications, this all combines in a very powerful tool for you that you can do very efficient design of experiments and even run multiple variants overnight with the tool. Having developed that specific film and application, you may then move forward to a pilot production regime where the Transform Lite platform allows you to add more capability and capacity. So you may be adding more process modules as a retrofit. You may be adding another capability. If you have a thermal batch, you may add plasma to provide that pre-clean and nitride deposition. And then importantly, with this combination of plasma and thermal, you may add also sequencing, pre-cleaning, nitride deposition, and thermal deposition. And worth pointing out here that usually the oxide processes are better done on the thermal batch process. So Transform Lite can walk you through from the technology phase all the way to pilot. If you're looking at increasing the tool capacity even further, then Transform platform may be your tool of choice. This is, of course, adding more capacity by adding a third process module, which means further cost down, first reduction of cost of ownership. And importantly, that platform has also some additional features, which I mentioned, like wafer cooling, integrated onto the mainframe that allows you to essentially extract further functionalities without affecting the tool throughput.
Greetings. I have a pleasure to introduce you Beneq B800 batch ALD system. B800 ALD system is one of the largest ALD tools in the market. Batch size is up to 40 square meters, so it's an excellent tool for production for different kind of parts. This is a production-proven ALD system and having large selection of reaction chambers. It's a really right tool to coat semiconductor equipment parts, optical components, large sheets, fuel cells, PCBs, and more. Usually substrate formats are different kind of sheets, different dimension of the sheets, complex 3D parts, and this kind of substrates. Substrate materials include glass, metal, silicon, ceramics, polymers. And typical coating materials are aluminum oxide, titanium dioxide, but also yttrium oxide, yttrium aluminum oxide, cerium oxide, and selected nitrides like titanium nitride, aluminum nitride. This is also a very good ALD tool to coat zinc sulfides for optical applications. B800 ALD tool includes selected number of reaction chambers, and therefore it's a very good tool for research and development and also for large batch production. So you can choose from 7 different reaction chamber options. In the case that you don't find the best option for you, we can customize chamber for your needs, and we can go even over 600 millimeter wide sample sizes when the chamber is customized. So it's one tool for multi-use, for research, development, and industrial production, depending on the materials and also the reaction chamber options chosen. This year, 2021, we have a new B800 facelift version, and the main changes include source cabinet. It's easier to handle. We have new cover plates, and then we have new Beneq control system for easy operation. New B800 facelift version also is more aesthetic outlook, so it's a really up-to-date for this millennia for ALD coatings. P800 tool is also excellent tool to coat either large number of small components or large substrates in one batch, like for semiconductor part applications for anti-corrosion coatings. When larger patches make ALD commercially feasible in wider range of applications, and here typical applications are anti-corrosion coatings on different parts, depending coatings for optics, electronics, and fuel cells. And it's also economically interesting when coating in large batch, because then the price per coating part is reasonable. Here we have P800 highlights, so I would like to summarize that it's an excellent tool for research and development, but also for production. We have tailored solution for each customer and high capacity for batch processes, so we have high throughput and low cost per piece. P800 is industry-proven solution, having thousands of small components or complex large parts. The tool has high-capacity precursors and pump line filters, so the operation is easy and maintenance interval is long, having minimized downtime. We have also a wide range of ALD processes for each customer. To find your best configuration and the tool you would need for industries or for research and development, please visit our website, beneq.com, and then you find P800 tool by selecting products and batch production equipment P800.
Hello, today I'm going to talk to you about Beneq C2R. So that is a new rotary spatial plasma enhanced ALD system, offering ultra high deposition rates up to micrometers per hour. And another advantage is that it makes naturally single-sided coatings, unlike many other ALD systems. The Beneq C2R is a batch process, so it has up to 7 pieces of 200 millimeter wafers or other substrates fitting the same area. It can be used for thick substrates such as lenses with up to 30 millimeter thickness. It offers high film thickness uniformity, which makes it especially suitable for optical coatings and such applications, which demand thick films and high uniformities. It can be equipped with a simple load lock or wafer automation system. Also, manual handling of lenses and such substrates through the top lid. Substrates are placed on the turntable and are rotated through precursor zone and plasma zone multiple times during the process. And one revolution equals one ALD cycle. So then we can run relatively high RPMs compared to the traditional pulsing of gases, which enable high deposition rates. So as an example, at 200 RPM, the ALD cycle time is 300 milliseconds. And on the right side, you can see the actual image from the tool. So this is there is a precursor zone and a plasma zone, just as illustrated in the picture on the left. And here on the top right image, you can see the overview of the system. It's relatively compact. On the bottom right picture here, you can see load lock installation on the side of the tool. And the bottom left picture shows the integrated precursor cabinet on the back of the tool, and also shows the lid opened for the maintenance. So the whole lid opens for easy maintenance and also for the substrate loading if no automatic loaders or load locks are being used. The top left corner picture shows the turntable itself and the substrate holder positions there. And this is image taken through the plasma zone. And also shows that the substrate orientation is face up in this system. About the precursor side, so we have 4 precursor sources, 3-liter canister volume, can be heated up to 120 C. Additionally, we have 3 plasma gas lines available for the plasma process. Some of the very first results with aluminum oxide. Here we have RPMs going from 50 to 100 and 200. And we see that the non-uniformities, this is the range, non-uniformity is around 2% for the whole area. And growth rates, deposition rate, with 200 RPM, we are at 1.5 microns per hour, which in practice means that it takes only less than 4 minutes to deposit 100 nanometers. So it's really, really fast. Quickly to summarize, it is fast, as said many times, and it enables the advantages of plasma-enhanced ALD in a production scale. Thank you for your attention.
What a great day of updates and announcements. We feel that all of these products are pushing new technology limits and making it easier than ever for our customers to adopt ALD. And there's one more thing. For years, our customers have relied on Beneq's P-Series tools for large-scale ALD batch production. This is particularly true if you need to coat a large, perhaps irregularly shaped substrate. The story begins with the Beneq P400A, which features an ALD vacuum chamber at 40 centimeters or nearly 16 inches in diameter. Its bigger cousin, the P800, houses an even larger vacuum chamber at a diameter of 80 centimeters or over 31 inches. We're now building the world's largest ALD reactor with a vacuum chamber at a whopping 170 centimeters or nearly 67 inches in width. Here you can see its size next to a passenger car. Here is a real-life photo of the tool in assembly. We are excited to announce this new product on September 1st this year. Thank you everyone for being with us so far. And with that, we're happy to proceed to our question and answer segment of this event. So we welcome anyone who has questions on the products and the customer case example that we addressed today to come forward. So the first question from the audience is, what are the special requirements for the precursors in order to be used in the roll-to-roll ALD?
Okay, Leah, I can address on that. Thank you, George, for your question. I think we can start with the fact that the precursor for the roll-to-roll, similarly to batch ALD, should have a sufficient vapor pressure. We do, although we have a little bit more flexibility in the roll-to-roll mode, since we introduce the precursor continuously to the point of web, and the manner that we usually do that is with the assistant flow, basically so-called birching mode of precursor. So we have operated also with a little bit lower vapor pressure chemistries in the roll-to-roll, and that has that flexibility. But just a short answer, sufficient vapor pressure. And then, of course, the chemistry has to match the ALD.
Thank you, Tommy. George, we hope that answers your question. There was a follow-up question from George regarding what kind of pump will be used for the 170 centimeter wide ALD tool. Unfortunately, this will be a brand new product that we will only announce publicly on the 1st of September. We ask for your patience and stay tuned with us. Until then, we will share a lot more details on the workings of this tool. A second question from Mathieu that we have, so you spoke about the deposition of aluminum nitride. Is it possible to control the orientation of this precursor?
Yeah, I believe this aluminum nitride that was part of the Mikko's presentation, if I remember correctly. Of course, nitrides in general, they are quite challenging for ALD. So I believe that there are some challenges to control the orientation of ALD. I mean aluminum nitride in ALD, yeah, I would like to ask to get back to this in a more detailed. Maybe we can exchange the contact information, and I can get back to you on this.
And thank you, Mathieu, for your question. Are there any other questions from the audience? If you do have a question, feel free to unmute yourself and ask the question verbally as well. And perhaps one question from our end for Stephen from our partner organization, the National Renewable Energy Laboratory. So Stephen, what would you say are the most surprising findings based on the work that you've done?
Well, like I was alluding, the really low coating loading, that's, I think, attractive from a lot of reasons. If we're coating powders, it makes it a faster process. You don't have to spend all day. And yeah, just the doors that this is opening up, I think will be pretty interesting. We have some other work that's, I'm not sharing yet, that's pretty exciting with respect to ALD modified metal hydrides. So stay tuned.
Thank you, Steve. Okay, we just received one more question. This is from Numiet Kailin. Can we also use a solid precursor with your tools? If so, what kind?
Well, short answer, yeah, I'll take that. Yeah, the short answer is yes, and it's basically comes down to the fact that the similarly to any other precursors, it has to have, or we should be able to create sufficient vapor pressure. Our sources, depending on the tool, just looking at, for example, TFS 200, we have a source temperature up to 300 Celsius or centigrade, or even up to 500 centigrade in case you are experiencing or investigating some new chemistries or new type of precursors. Our bigger industrial tools can handle the source temperature up to 200 and even above. So those are basically the limiting factors. But yes, solid precursors can be used in our sources, and they are usually heated.
Thank you, Tommi.
Thank you.
On that note, we'd like to thank everyone who was present today for joining us. We cannot be here today without your support and all of the inputs from the ALD community. And once again, thank you. A big thank you to the organizing community at AVS for the ALD conference for featuring us as a manufacturer virtual room. So we hope everyone have an excellent summer ahead, and let's stay tuned. Thank you for joining us.
Thank you, everyone. Thank you.